Hello students, welcome to IMS Gate Academy. In this foundation course, I started EDC subjects from March 2nd. So far completed one class itself. But for 10 classes, I am going to take EDC subjects. But in these subjects, I started semiconductors. All these 10 days, you are going to find semiconductor topic. I started from the basics, but I will enter into the main topic, and we can enter into the depth also then. Understand? I said already, I am going to do the theoretical part wherever it is required, and also I will do wherever the analysis is required, and also I will do certain number of the problems selecting from the GATE and IES. Surely you are going to get satisfaction. Please try to attend. Please share this link to the what now? Your friends also. Understand my point now? Yes, I can start the second class here now. But in the last class, I said, Pragya Tripathi. Hi, Sarah. Yes, hi. Yes, now I will start the conductors. In the last class, I said, what is the definition of the insulator and theory regarding the insulator I completed. And I explained well about the conductor. The information regarding the conductor also I gave it, energy band diagram, and more information I gave it now. In today's class, I am going to discuss transport mechanism of semiconductors. Different parameters you are going to find in the transport mechanism, mobility, and also current density, and also resistivity, conductivity, mass action law. Like that one after another we can discuss. Once we discussed the transport mechanism of the conductors, I can enter into semiconductors. Then subject becomes very simple. Without knowing these basics, you cannot enter into the semiconductor part. Understand my point now? Yes, I will start now. Now, few more definitions very important in the transport mechanism. The first one is, I will give now one by one. Mean free path. I want to give the mean free path. Mean free path. These are the definitions very important. Mean free path. What is mean free path? Suppose I selected any conductor. In a conductor, like whenever you applied any electric field, any supply is connected, what is going to happen? Electrons are going to move. When electrons are moving in a conductor or semiconductor, they can hit other electrons also. That means collision is done in the material. Electrons are connected by any external supply. They are going to move and going to hit any particular electron in a semiconductor or conductor. When electron hits any other electron, we can say that as a collision. Collision is going to take place now. Collision can be defined in different way also. When the electron is moving in a semiconductor and trapped in any hole, that also called as a what? Collision also. We know very well, when electron is trapped in the hole, we can call it as a what? Recombination. And also we can call it as a collision. As a collision means here now hitting of electron to the other electron. Otherwise, recombination with hole also we can call. So finally, how we can define mean free path? The average distance covered by electron between two collisions is called as a mean free path itself. I am defining here now clearly now. The average distance covered by or traveled by, distance traveled by, best word, traveled by what? By electron. That is very important. by electron between two collisions. That's very important. Between two collisions is called mean free path. Mean free path. In a simple way you can define. Between the two collisions it covers some distance. The distance is nothing but the mean free path. That's why mean free path can also be denoted by symbol L. Some distance covered by the electron between the two collisions only now. So that is one of this definition from the conductors. And one more definition also more important. First let me complete these definitions. Next one I can define. One more is more important now. Mean free time. Mean free time. This is generally denoted by symbol tau. Tau is the symbol is generally used. How we can define this mean free time? The time taken by the electron to cover the mean free path. To cover the mean free path, some time it is going to take only. That means between the two collisions some distance is covered. The distance we are calling as a mean free path. To cover that distance it takes some time. The time is called as a mean free time. The time taken for an electron to cover the mean free path is called as a mean free time only. You can write now. The time taken by electron to cover mean free path is called mean free time. You can define mean free time. You can define. There is one more definition, it is required. But all these definitions will be useful shortly. That's why I am giving now. One more is more important. Drift velocity. We are going to use so many times this drift velocity. We are going to say drift velocity. What is the drift velocity? That's very important. What is drift velocity? V suffix small d. You can give the name. To cover mean free path, the electron is going to move with some velocity. That means the velocity attained by the electron to cover the distance between the what? Two collisions is called as a what? Drift velocity only. Definition we can give now. The velocity attained by electron to cover mean free path is called drift velocity. We can call drift velocity. But in the case of drift velocity, you should understand one point. You take a conductor, for example, without connecting the external supply, you will not find any drift velocity. But if the conductor is connected here, the conductor is taken, means electrons are moving inside or not moving inside of the material. They will move freely. But that path is a irregular path, not in one particular direction. If the supply is connected to the conductor, all the electrons are going to move in a uniform path, in a regular fashion. They are going to move only now. At the time only, we are going to call the velocity of these electrons is nothing but the drift velocity. We can say it now. That point very important here now. But how we can measure, how we can find the drift velocity? That's very important. After drift velocity, you will find the so many things here now. But according to the, just I will give, law of conservation of energy, I can get, according to law of conservation of momentum, according to the law of conservation of momentum. This point is very important now. Momentum applied is equal to momentum applied is equal to momentum is applied is equal to momentum gain. Momentum gain. Based upon this condition only, velocity is calculated only. How that will be calculated, sir? I'll give, just see that now. After this, I will clear it now. Momentum applied is nothing but the force into time. What now? We can write now. The force into time, clearly I will know. Momentum applied is nothing but the force into time. These are all physics sentences only now. Force into time. Momentum gained, momentum given there, momentum gained is nothing but the mass into velocity they will put. Mass into velocity. We are going to use now. But everybody knows what is the force. Force equal to charge into electric field intensity. You know very well. But a charge into electricity is what the electric field intensity. That means with minus they will put minus Q into E is said to be force. The time is nothing but the mean free time. Already given definition. There is the tau. Generally they will use tau. Mass is nothing but m. I can put now mass. I can put the m. The mass of, because there is a conductor, in the conductor you can find mass of electron, m suffix n I have taken now. Even tau n I can put now, mean free time of electron. Electron indicates n. Velocity I would like to denote by symbol v suffix n. Vn, velocity of electron, that only drift velocity. Velocity of electron is nothing but the drift velocity only now. But here I can write what is the Vn value. Vn equal to minus Q into tau n divided by m suffix n, mass of electron into electric field intensity with minus sign. We are getting here now. But the point you try to understand, minus Q into tau n by mn is what now? Taken a symbol of mu n. That means mu n is the symbol I have taken for minus Q into tau n divided by mn. Mu n symbol I gave it now. These are all the terms are given a name of mu n. Where mu n is given a name mobility of electrons. Where mu n is taken a name mobility of electron. What is mobility? I will define. Mobility of electron. Mobility of electron I can say now. So whenever you want to find out the mobility of electron, it must be taken with a magnitude only now. In magnitude means sign should not be considered only now. But here exactly what now with sign I want sir means minus is a must only for mobility only now. Understand now? Anyhow, mobility of electron can be calculated by charge into mean free time divided by mass of electron they will put only now. Now finally velocity Vn or Vd also we can put now, no problem. This value is nothing but the mu into E, mobility of electron into E. Yes, the formula you must remember. What units are to be taken? Mobility of electron is taken as a meters per volt second. Volt second or centimeters per volt second it is allowed. Centimeters per volt second, meters per volt second or centimeters per volt second. Drift velocity we know meters per second or what now centimeters per second also accepted. These units are very important in the electronic devices and circuits. So, that's why I am giving all these now. Understand my point now. The information is required regarding the drift velocity. Next one. The next one what I wish to give here is a mobility. How we can define the mobility? Exactly. Mobility means I give some formula. How to define mobility? It is a mu we are putting. For electron means mu n, mobility of electron. For example, I selected here, I selected one conductor. I selected one conductor like this. This is one of the conductor. This is the conductor I have taken. And I connected one more conductor also. Two figures I will draw. I will explain. Like that, two conductors I selected. But in these two conductors, what I wish to say is the figure 1. This is figure 1. In the figure 1, I didn't connect any external supply. This is the conductor. But in the conductor, how the motion of electrons, you can find. The electrons will move in an irregular path. They are going to move in a zigzag path. Also we can call. Any side they are going to move only we can say. Any side they are going to move irregularly. But I selected the what now one more same conductor I have taken now. Otherwise one more conductor or same conductor, no problem. This is a figure 2. But here I connected with external source like this. I connected. This is negative electrode, this is the positive electrode. Supply voltage is nothing but the V. In this here, in this figure 2, all the electrons are going to move in this path. They are all going to move in a straight path or uniform path. The path is attained by the electrons. These are the two figures. These are the two figures are possible. But in this case, the point what I wish to say, for the figure 1, it is not connected any external source. But I explained in the last class, any conductor can have free electrons of more. Because the valence band and conduction bands are overlapped one over another. At the time we can find the free number of free electrons in the conductor. Can you find any number of the holes in the conductor means we cannot find a single hole so far. In any book it is not specified the existence of the holes in the conductor, only electrons, the free electrons will be there now. But these are the free electrons are going to move in a zigzag path or irregular path. They are not going in a one particular direction only now. Some students may get one doubt. Sir, there is a conductor. Inside of the conductor, there are number of electrons. You said all the electrons are going to move freely. We know very well the definition of the current. The flow of electrons is nothing but a current. So in a semiconductor, in this conductor, if there is no supply, electrons are moving, sir. Can I find any reading of the ammeter if I connected between the two terminals of this conductor? Catch my point. Electrons are moving in a conductor. I connected across this material one ammeter to identify what amount of the current is passing in the conductor without external supply. We cannot find any reading of the current. Ammeter will not show. Then how can you say electrons are moving in a material, sir? The electrons are moving means we know that current must flow only. But meter reading is a zero only now. Very simple reason we can give here now. Electrons are not moving in a one particular direction, irregular path. Suppose you take a ball, you throw it, but in front of the ball, whenever you are throwing the ball, in front of you there is a wall, for example. It hits the wall and comes back. It hits the ball, that wall, and comes back only. Now try to catch. When the electron is moving to the front, they will hit any electron and comes back, bounces back only now. The positive, whenever it is going to the front, some current is possible. Whenever it comes back, some other current is possible with opposite sign. Those two will be nullified. Finally, the net current in the conductor becomes a zero only now. Because of the collisions, what happened now? Net current becomes zero only now. That's why you cannot find any reading of ammeter, even if it is connected to the conductor only, we can say that now. Now what I did, for the same conductor, I connected external supply like this. This is nothing but the negative electrode, this is the positive electrode. The conductors contains number of electrons. Electrons are negatively charged, conductor is negative. Negative, negative. What happens? Force of repulsion. Force of repulsion is generated here now. Because of the force of repulsion, all electrons are repelled towards the direction of the positive electrode, because the positive electrode is going to attract the negative charges now. In this case, because of the existence of the force, all the number of electrons in a conductor going to move in a straight path or in uniform path. In that case, current flow is possible, because we are not finding bouncing back of electrons in this material. The force is making the electrons to move in a straight direction only, we can say. Now catch my point. Now there is a velocity of electron. What velocity had by these electrons? The existence of the supply is there now. External supply, if it is connected, we can say drift velocity will be there in the conductor, we can say. So how we can measure this drift velocity, sir? Drift velocity is directly proportional to electric field intensity. First of all, here the mobility definition is required. We want to find out the mobility. How we can define the mobility definition? The free movement of electron is called as a mobility. How much free movement of electron is existing in the conductor we need to calculate. To calculate, we are going to take the mathematical formula of drift velocity. Using the drift velocity, we can determine the mobility. So drift velocity is directly proportional to electric field intensity. What is electric field intensity? Means I will give later. Electric field intensity means everybody knows. Voltage by supply voltage by distance covered by the electrons. L, V by L. Can give the electric field intensity. Voltage by length. Here anyhow drift velocity is directly proportional to electric field intensity, and Vd equal to proportionality constant is possible. That proportionality constant is to be taken as a mu. mu n. What is the mu n? Mu n is nothing but the mobility of electrons. So if you want to calculate mobility of electrons in a conductor, you need to use the formula drift velocity by electric field intensity. Electric field intensity. Here I give the drift velocity now. Here what happened now? Drift velocity means what now? Meters per second, for example. Meters per second. Meters per second. Electric field intensity volts per meter only now. Volts per meter. Finally, meter square per volt second is possible. I think before I gave it meters per volt second, I will clarify that now. Here already units given. Here the meter square only possible. My mistake. Meter square per volt second or centimeter square per volt second. Just mathematically we got now. Centimeters per volt second is possible. Anyhow, so meter square per volt second possible. Otherwise, centimeter square per volt second also possible for mobility. Instead my point now. Like that we can find out mobility of electrons by using this formula. The formula we should apply to find out the mobility of electrons. I think you followed. But there are two ways to find out the mobility. One by using drift velocity by electric field intensity. Otherwise, one more formula I gave before. The mobility can also be calculated by charge into mean free time divided by mass of electron. This formula also you can use based upon the data given. You must use. Next one. But I would like to explain current density. That is very important. Current density in a conductor. Current density in a conductor. The current density I would like to denote the symbol of J. Current density I want to denote by symbol J. Suppose I selected here one conductor. The conductor I selected here. This conductor is connected by external supply here. External supply is connected here. There is a battery here like this. Because of the connection of the supply, just now explained, all the electrons are going to have uniform path or straight path. Electrons will try to move in this direction. But I would like to find the current density in a conductor. But you know very well, I will derive here now. Current density is denoted by symbol J. Current density. Because in the problems it is useful. Current density due to electrons only, J. Current density means current by area. We can write current by area. Each and every formula is very, very important. Current by area is said to be current density. But how to define that currents are mathematically? That is very important. The current is nothing. The mathematical formula for the current is charge by time. Charge by time. You will put charge by time. But in this particular conductor, we are not going to find a single charge carrier to move. Multiple number of electrons are moving. How many number of electrons are moving? We can say n number of electrons are moving here now. That n I want to take capital N. Charge is nothing but n number of electrons, Q or E allowed. Q or E is allowed. Number of charges are moving. Divide by time is a T. You know very well from the physics, From the physics, you know, distance equal to velocity into time. Velocity into time, you know very well that formula. If the distance I want to denote by symbol L, some distance it is covered, electrons. I want to denote the symbol L. Velocity I have taken V. The time is denoted by symbol T. Here I want to get what is T here. T equal to, I can say L by V. I can write T equal to L by V. Every formula you need to know. So the current formula I can write like this. NQ by T. T is nothing but L by V. L by V. Suppose in a problem it comes a necessity to find out the current, you think it's so. In different way you will find current equal to voltage by resistance allowed. Otherwise current equal to N into Q into V by L also allowed. Now this current I want to substitute in this particular equation. Now I can write current density, I can write like this. Current density J I want. I said current by area is nothing but the current density. I got already current NQV by L. NQV by L. NQV by L. NQV by L. That is the current divided by area. Area I will put A. That is taken A. Follow this. If anybody having any doubts, they can arise. But you know very well, length into area equal to volume, you know very well. Length into area equal to volume. I can say volume equal to length into area. But I don't want to take any symbol for the volume. If I have taken this small v, the student will say immediately now, V is the velocity, sir. If I have taken volume equal to capital V, students will say voltage, sir. That's why I don't want to take any symbol for the volume. I will put as it is now. Now current density J, I can write like this now. N into Q into V divided by length into area is nothing but the volume. I am going very slow. This is a foundation class. It must reach to the every student. Subject must be reached to the every one of the student. That is very important. But one more formula here I can create. In the problems it is useful. N means the number of charges are moving. N by volume. Number of charges per volume is called as what? Any student having any idea? Number of charges per volume equal to what formula? Any student? Any student can give answer? I can write concentration. So I can write one more formula. Concentration. Suppose in the problem it comes necessity to find out the concentration. Concentration is denoted by symbol small n. There may be concentration of electrons here now, because in the conductor it is going to flow the concentration of electrons. That is denoted by symbol n. What is concentration? I said number of charge carriers divided by volume. Number of charge carriers per volume is said to be concentration. So I can write clearly N equal to number of charge carriers means N only. Don't take N into Q, only N only now. Volume, N by volume. I can write N by volume is nothing but the concentration. This is one of the formula. You must remember. Every formula is very important. One more formula also you can create from this one. N into Q. What is exactly N into Q? Clearly what we can give. N into Q can also be called as a, what is the name it is to be given? N into Q. Charge density also we can call. Charge density is nothing but number of charges into Q. Charge density. Charge density is denoted by a symbol. In certain textbooks, they will put the symbol rho. The rho can also be used for the resistivity only. That's why I don't want to put any symbol. Just for understanding, I am giving you. Suppose you are asked in any examination, find out the charge density, capital N into small q. You must take one now. Understand my point? Charge density one more name. Now finally, J equal to what here? N by volume equal to small n. Q into velocity of what? Electron only now. N into Q into V. The formula you must remember to find out the current density. What units you can give for the current density? Current density starting definition you watch, it is the ratio of current to the area. Current by area I said now. Current means amperes, area means cm square. Amperes per cm square is allowed, or amperes per meter square also accepted. Anyone you can use. Amperes per meter square also required. This is current density formula. Still the modification is required, means one more way also that formula I can modify. The V means velocity of electron. Velocity of electron equal to, just now in the mobility I defined, the V proportional to E, V equal to mu E I gave it now. V equal to mu E. So in the place of this V, I can put mu N into E allowed. One more way. I can write current density can also be written as a N into Q into velocity is nothing but mu N into E also allowed. This way also you can find current density. Suppose in a problem directly velocity and also concentration is given, is last formula, previous formula. And concentration is given, mobility is given, electric field intensity is given. In that case, we need to use this formula to find out the current density. Next one. I said one more way already. NQ means what now? Sorry, here the capital N means now N small n into Q. Charge density N into Q. This only now. Anyhow, we can write now. Charge density means N into Q. I said capital N into Q. That is a charge. Small n into Q. Small n into Q is said to be charge density. That is why. Please cross check. N into Q can also be called as a charge density. Exactly. Not capital N. Small n only required for charge density. Okay. Anyhow, current density means N into Q N into mu N into E only now. Next, one more definition required, conductivity. Conductivity. If it is required conductivity, how you will find? And still this formula you can write if you want one more way also you can write. How means I will write, you watch. But after knowing the definition of the conductivity, this formula you can change still. I say conductivity. Conductivity is denoted by symbol sigma. I said just now, conductivity, what charge density means what now? Small n into Q, not capital N, small n into Q. Otherwise, I'll write best. Charge density. Charge density is nothing but N into Q. N into Q allowed, not capital N, small n only now. The Q, what are the units? Q means coulombs. Concentration units per meter cube or per cm cube is allowed. Coulombs per meter cube is allowed. Or coulombs per cm cube also allowed. Charge density can be given a symbol of mu, what now? Rho also allowed, I said now. Understand? Rho also accepted. But a conductivity definition I can give like this. It is the product of charge density charge density and mobility. The product of these two said to be conductivity. How we can write the formula for this? Sigma equal to, I can write charge density means N into Q. Mobility means we know mobility of electrons, mu N. Finally, this formula can be taken as a conductivity. Conductivity is allowed. Like that we can find conductivity is required. Suppose the resistivity is required now, but by using the conductivity you can write current density in some other way also. Current density is nothing but the J, you know very well. Suppose in a problem you are given the conductivity, electric field intensity is given. You can determine J value because N into Q into mu N is nothing but the sigma. I can write one more formula, conductivity into electric field intensity. This formula also allowed for current density. Conductivity into electric field intensity is said to be current density. Conductivity is nothing but the charge density into mobility is required. Understand my point now? Followed or not? But what are the units of the conductivity? Conductivity units if it is taken. The units equal to conductivity units. What units you can put? Units are mho per centimeter or mho per meter also allowed. That is allowed. Like that we can find the conductivity. So in the problems it is useful this formula. Sir, why you are giving all these definitions? It is a foundation course. Every point is more important. Understand my point now? Next one, I want to give resistivity. Resistivity. Resistivity is given a symbol of rho. We can give the rho symbol. But the resistivity means it is the reciprocal of the conductivity. Reciprocal of conductivity is called as a what? Resistivity. You know. You can write it is the reciprocal of conductivity. It is the reciprocal of conductivity, you can say. Finally we can write resistivity rho is nothing but 1 by sigma. I can use sigma equal to, just now I have done N into Q into mu N. So by using this formula, resistivity of conductor is so calculated. What units you can give? Ohm centimeters. Units are ohm centimeters, or ohm meter also you can take. Ohm meter also allowed. These are all the units you must take only now. Follow this. If any students are having any doubt, they can arise based upon this. Next one. I gave all the parameters of conductivity. Next one. Now, before going to the next session here, I would like to give some information. Yes, the session is conducted by the IMS Gate Academy. If the students are willing to take the admission in IMS Gate Academy, here given the phone number, mobile number is given. They can make a call and they can contact with the people. They will get the right information. Every information they will get it now. Sir, if I join in IMS Gate Academy, what those benefits I can get? Here given program futures. 800 plus hours of the live classes with the live interaction is possible. But all the faculties are experts only now. All the faculties are having the experience of more than 10 years experience only now. They are all ready to give the right information, the proper information, proper subject they are going to give only now. And IMS GATE Academy is going to give theory book and exercise books for the students who join in our institution. But exercise book contains more than 4,000 questions. These questions are just enough. It is not required any other textbook to tackle the question. All the problems are given here itself now. So those problems we can practice. But in the exercise book it is given level 1, level 2 and level 3 questions. All 3 levels are given here now. And also 34 plus years GATE question banks with video solutions are given. But here the GATE questions, previous GATE questions are solved 34 years plus years GATE questions are given. And for certain questions video solutions also given. Not only that, alternative solutions also given in this GATE solution book now. Understand now. And 12 one-to-one mentorship sessions possible now, personalized. But each and every one of the student is given a chance to have the mentorship session only here now. That means directly the students can discuss with the faculties. The faculties are going to guide how to achieve the goal, how to prepare, how the time management is to be made. Everything you will get from the mentorship session. 130 plus online tests with video solutions of the mock test and many more possible. So I am saying the students are ready to take the admission in IMS GATE Academy. This is the contact number. You can make a call. Okay, anyhow, I completed today the mechanism, but now transport mechanism of conductor. In the next class, I am going to start semiconductor. In the semiconductor, I will discuss different parameters. Easily you can understand. Don't miss the class. The next week on Saturday, exactly at 4 o'clock, I am going to start. Okay then. Thank you.